Hey guys, today we're going to be going over the last lesson of chapter 1. This time we're going to be doing both surface area and volume, but of composite shapes, which are shapes made of multiple other shapes attached to one another. So let's get into it. So this is lesson 1.7, composite objects. Once again, we will be using all of our formulas from our formula sheet. Volume is pretty easy when it comes to composite objects. To find the volume of the composite object, you just take the volume of each individual object and then add them together. Surface area is only slightly trickier. You do need to find the area of each face, just like we do when we're finding the surface area of a single object. The one kind of extra step is you also have to find the area of any areas of overlap, which are the areas where two different objects touch one another. And then to figure out what the total surface area is, you just take the area of all the faces and add them together and then subtract the areas of overlap. So we're just going to be going through one example here, but I've asked you to find both the surface area and the volume. So what we have here is a rectangular prism on the bottom, then we have a cylinder and a cone. But you could see a composite object that has any of these shapes listed on your formula sheet. So I could have like a hemisphere up here. I could have a pyramid, which we did in the first lesson. I could have a triangular prism, which is like where you have a long triangular shape thing. But yeah. So I'm going to start by going through how to solve for the volume because that's the easiest part of this. So I'm going to start by finding the volume of my rectangular prism. So to do that, I just do my volume is length times width times height. You don't have to write out the formula if you don't want to. You just plug your numbers into it. So 30 times 10 times 3 which is 900, and I will circle that so I know I need to add it later on. Then I'm going to do the volume of my cylinder. So for that, the volume is pi r squared h. In this case, my r will be half of the diameter, so half of 5, which is 2.5. And then my height is 8. 2.5 squared is 6.25. I'll times that by pi and by 8. And get 157.08. Circle it so I know I need to add it later on. And then for the last volume, I need to find my cone. But the one thing you have to remember whenever you're dealing with cones or with pyramids is that slant height, which is what I have here, is only useful for surface area. When it comes to volume, I need to be using the internal height, which is that amount in there. So to do that, I'm going to make a right triangle like so. The base of this triangle is half of the entire diameter, so that is 2. And then I can use Pythagorean theorem to solve for my internal height. So my height is going to be a squared plus b squared equals c squared, where I don't know my a squared. My b squared is 2, and my c value is, of course, my hypotenuse, which is 6. I'm then going to subtract 2 squared to move it to the other side. That leaves me with a squared equals, and then 6 squared minus 2 squared is 32. And of course, my last step is to square root it to get the a by itself. So the square root of 32 is 5.66-ish. So now I can go over to my cone. The formula for the volume of a cone is that the volume is 1/3 pi r squared h. So 1/3 pi. My r value is, of course, half of 4, so that's 2 squared. And then the height must be this internal height, not the slant height. So 5.66. So I'll multiply that all together, 1 divided by 3 in brackets, times pi times 2 squared, which is 4, times 5.66. And I get 23.71. And now my last step to find the total volume is to just add these all together. So my volume total is 23.71 plus 157.08 plus 900. Which is 1080.79, and volume is always units cubed, so it will be centimeters cubed. That's your final answer. Okay, so only like 5 steps really, including adding it all together. Next up, we're going to do the exact same composite object, but we are going to find its surface area instead. Okay, so down here on this extra piece of paper, I'm going to be working through my surface area for this composite object. And I'm just going to start one face at a time. I always like to start with anything that's like rectangular because those are just easy to work with. So I'm going to start by going through the different faces on my rectangular prism. Again, it doesn't matter what order you work through these different faces in, as long as you cover all of them and make sure that you are labeling really clearly which faces you're working with. So I'm going to start with that area right there. So number 1 is a rectangle. It is just 30 by 3. This is a 3, just like that. So 30 by 3, length times width is 90, I think. Yes. And then because the back of this rectangular prism is the same, I will multiply by 2, which gives me 180. I'll circle it so I know I need to add it later on. Next up, I'm going to come to that rectangular face over there. So area 2 is 10 by 3, which is, of course, 30. And then this side over here is the same. So I will times that by 2, which is 60. Circle it. And then next I'm going to do the top. Oops, that's number 3. So that shape up on the top there is 30 by 10, which is 300. And because the bottom of this shape is the same, I will times it by 2, which is 600. Yes. I don't know why I don't trust myself to just know this without double checking on my calculator, but I don't. Okay, so that's it for our rectangular prism. Next, I'm going to go on to our cone. So I'm going to be finding the curved surface of the cone. That'll be my 4th area. So for that, I'm going to look over here. The curved surface of the cone is pi rs, where s is slant height. So pi times the radius, which is half of 4, so 2, times the slant height, which we were given, of 6. Plug that all into my calculator at once. So pi times 2 times 6, which is 37.7. And there's only one of those, so I don't multiply it by 2 before circling it. The next thing that I would do, just because I'm on the cone now, is to identify the area of overlap that we're dealing with at where the cone touches the rectangular prism. So that would be right here is my area of overlap. It's the circular face on the bottom of the cone, and that face is covering a circle on the face of the rectangular prism. So this face of the rectangular prism that we already calculated, we determined that it was 300. It actually has a circle missing out of it, a circle where it's covered. So I'm going to figure out what that area of overlap is. So I'm going to call that A of O, number 1. So to do that, that is obviously a circular base. So it is pi r squared is the area of a circle. So pi, the radius is 2. So pi times 4 is 12.57-ish. Now I'm not going to circle that because I don't want to add it later on. Instead, I'm going to put like a cloud or something around it, so I know that it's something that needs to be subtracted later on. And then we get to our last shape, which is this cylinder here. I'm going to start by finding the area of this curved face of the cylinder. So what number am I on? That's area number 5. And the curved surface of a cone is pi r, oh no, it's not a cone, curved surface of a cylinder, 2 pi r h. 2 pi r h. So 2 times pi times the radius, which is half of 5, so 2.5, times the height, which is 8. And I'll multiply that all together. And I get 125.66. Circle it so I know I need to add it later. And now we get to the last face, which is this circular face on the top of the cylinder. But I do also have another area of overlap here, which is the circle on the bottom of the cylinder. Now you could, if you wanted to, calculate the area of this top circular face, which would be added to the total surface area. And you could also calculate the area of the bottom face, which would be an area of overlap, and it would be subtracted from the total surface area. But because in a cylinder like this, the area of the top face and the area of the bottom face are the same, they're going to cancel out. This top face would be added to the surface area. This bottom face as an area of overlap would be subtracted from the surface area. You would just be adding and then subtracting the same number. So you certainly can calculate both of them, add one and subtract the other, or you can just say those two faces are going to cancel out with one another. That didn't happen with our cone because this area of overlap on the cone doesn't have an identical area on the surface. But in this case, those two areas do cancel out. So I'm just going to cancel them out. I'm not going to bother calculating either one. And that means all that's left to do to calculate my total surface area is to add up all of my areas and subtract my area of overlap. So yeah, let's do that. My surface area is going to be 180 plus 60 plus 600 plus 37.7 plus 125.66 minus my area of overlap of 12.57. 180 plus 60 plus 600 plus 37.7 plus 125.66 minus 12.57. And we get 990.79. Okay, sorry. Okay, and that is our final answer. Now, some people do like to subtract this area of overlap directly from one of the faces, like this 300 here. That's fine too. I just like to save it all to the end, but if you'd like to deal with the area of overlap earlier than that, you certainly can. But yeah, as long as you're really clearly showing your steps, everything is clearly labeled, both on here and on your diagram, then even if you miss a side or miss an area of overlap or something like that, you'll still get lots of part marks. Hopefully I haven't done that, but let me know if I have, or if you're getting a different answer than me. But yeah, that is it for composite objects. Make sure you know how to, deal with this kind of question, regardless of what shapes your composite objects are made of. Yeah, that's it for this chapter. Let me know if you have any questions.